Thank you for once again attending this. We are yet continuing with what we started last time. It is just a continuation of what we did when they started. We are on the measures used in physics practicals. We looked at some of them and then telling us those few that we were able to look at last time, those instruments that we did look at last time and we use in physics practicals. Can we just remind ourselves within 1 or 2 minutes? Those who are there, Mukisa? Mukisa, thank you for the response. Trevor.
Yeah, we looked at a vernier caliper, a half meter rule, a meter rule, and a micrometer screw gauge.
Very good. Those were some of the things that we looked at. Any other that we did look at, but that Trevor has not mentioned? So we also did look at micrometer screw gauge. I think mainly we looked at the instruments for measuring length that time. Though we moved on also to look at protractor as well, stopwatch, stop clock. We looked at how we can be able to use those ones to measure in physics practicals. So just a continuation of that, we are proceeding to look at now ammeter. What is ammeter? I just want us to have that diagram there. What is ammeter? Who's trying to respond? Trevor?
An ammeter is an instrument used to measure the power in amperes.
Is an instrument used to measure power in amperes. Can someone clarify on that? Is that correct? No, we are trying to remind ourselves of what we did look at. Even these are the instruments that you commonly use when you are in senior folk, as you are finalizing your O level. It is true that ammeter measures in ampere, but it is used for measuring. It is used for measuring what?
Current.
Trevor. Very good. It is used for measuring current. So if you want to measure current in a circuit, so you'll be using an ammeter. We have the ammeter, which is commonly used. We have there's one range of ammeter which is commonly used in the laboratories. If you go to most of the laboratories, the common the ammeter that we have in the laboratory, the common range we always use is that runs from 0 to 1 ampere. So if we can just come to the structure of this ammeter here. So when you look at the structure of the ammeter, see, sometimes we do not know. If we were to look at how physically the thing appears, you may not be able to differentiate between ammeter, voltmeter, and even galvanometer, those others. So, but how we do always sort out ammeter from those or from the rest is by looking at the scale where, I mean, the interface where we have the scale. And then we look at that simple for, of the unit, simple of the unit for measuring current, which is the ampere. So if you have that A on the interface, just know that that is what? That is an ammeter. So you can see an ammeter, we have many, as I've said, we have so many of these ranges, which means there are many in the lab there that measure current. We have this is a multi-purpose. I mean, in fact, it has a double scale. This has a double scale. The one we have here has a double scale. There's a scale that runs from, who can identify for me the scales from this ammeter here, the two scales that we can be able to see from here.
Went from 0 to 1, the other from 0.
We have 0 to 1, very good. The other one?
0
to 5.
0 to 5, good. There's one from 0 to 1, then the other one is from 0 to 5. You see, it has two scales. So now, how do you use it if you want to measure, to measure current using the scale that runs from 0 to 1? What you do is you will connect one of the terminals. In this case, you can say the negative terminal on the black one here, black terminal here. Then you'll connect the other positive terminal on the red terminal, which has what? 1. You see where we have 1 there, beneath the terminal, we have 1 there. So that is where you'll be connecting the other connecting wire. So, which means now here, when one is connected on the black here, the other one is connected to that one, you are now using the 0 to 1 range. But now, if you want to use the range that runs up to 5, so what you'll do is you connect one of the terminals to this one, which has actually just a different color, the black one, then the other one, which has now the what? The figure 5. Is that clear? But
yes.
now, there are cases where you go to the lab, you find they are just having 2 terminals, and then the scale there will be 1. For example, there will be a scale running from 0 to just 5 like that. Then there will be this terminal and then the other one. So you just automatically have your connections there. Or else you have 0 direct to 1. Then you automatically connect to the 2 terminals which are given there. But however, after your connection in the circuit, if it happens that the deflection of the deflection there is in the anti-clockwise direction, it is going to towards the left of 0. What you can do is you interchange the terminals, the connections. You interchange the connection from the terminals. Then right from there, you'll be able to have a very clear, and the reading will actually be just in one direction, and the deflection will be in one direction, and then you'll be able to have your recordings easily. So now when we take this, which has a scale running from 0 to 0 to 1. This one, which has a scale running from 0 up to 2, you realize that they are 10. Is that true? Can someone try to confirm for us if they are 10? Are they 10?
They are 10.
Yes, they are 10.
Yes, from 0 to 0.2, they are 10. Now, from this, we are trying to now derive the accuracy. You'll find that now the 10 divisions are representing what? 0.2 ampere. Is that okay? The 10 divisions there are now representing or are equal to 0.2 ampere. Now, what will one division be giving you? See, what will one division be giving you? So a division is actually equal to dividing the 10.
0.02.
Dividing 0.2 by 10, which gives you 0.02. Now, which means wherever the deflection is going to be, if you want to get the value of the current at that point, what you'll do is you will count the number of divisions and then you'll multiply here by what? 0.02. Is that okay? You'll count whatever, how many divisions are there, and then you'll multiply by 0.02. So that is how you can be able to determine a reading from an ammeter. However, as you are trying to work on this, don't always forget that I've tried to come up here with the one range now, which is from 0 to 1. There's going to be time where you're going to be asked to use that from 0 to 5. So just to know that when you are using the range from 0 to 5, yours will be that from 0 to 1, you now take, instead of 0 to 0.2, you take now what? 0 to, you'll now take that from 0 to 1, yeah. From 0 to 1, there are 10 divisions. Then, which means 10 divisions are now equal to 0. I mean, not 0, but equal to now the 1 ampere there. So what will one division represent? One division will now be representing 1 divided by 10. So when you divide 1 by 10, what do you get? When you divide 1 by 10, if you get
0.1.
you get
0.1.
Good. So you get 0.1. You get 0.1 ampere. So which means from there we conclude that the accuracy of that ammeter is 1 decimal place, and then all the recordings will now be in, which means to 1 decimal place. Meanwhile, for what we now have here, the common type that we always have in the laboratory, the accuracy of this one is 2 decimal places. Of course, the last digit will either be a 0 or an even number. Diction, when I mute you, I think you just have to be like that unless you're asked to give an answer. We can even put our cameras, I mean our video off to save data. Now I was just saying here, for this particular ammeter, the accuracy of the scale that runs from 0 to 1 is 2 decimal place. So you'll have the last digit in the decimal place either an even number or it is a 0. So as a result, you may get answers like 0. What? 10, 0.30, I mean 0.30, 0.34, 0.68, 0.92. Now I want to give an example. And I am posing a question here. What if our the pointer here is on the 0.6 mark there, and we wanted to determine the reading by using the method that I've just told you, by first finding the number of divisions, then later you multiply by 0.02. How many divisions are there from 0 to 0.6 here? How many divisions? How many divisions are there? Who's putting up their hand to give us an answer? How many divisions are there? Emmanuel. Emmanuel, there are what? How many divisions? I've only asked Emmanuel to give me an answer. We have Edwin. Edwin, how many divisions are there? You can't get Emmanuel.
30 divisions.
30. Very good.
Yeah.
Now, from the calculator, you are going to multiply 30 by the unity scale. The unity scale is 0.02. the accuracy. So you now say 0.02 times 30. What does that give you? That is what the work you'll do from the calculator. Nicholas. Still, Edwin, you can calculate for us that if you have a calculator around. What is 0.02 times 30?
0.6 amperes.
You'll get 0.6. Good. But now, as you are recording, as you are going to record, how will it be? How will it be on the sheet where you're going to record? How will that answer be? Manuel? Manuel, you can give us an answer in the chat because we can't get you clear. Trevor. Trevor. 0.60. Correct. So you have to bring in, the last answer. I mean the last zero there, in order to cater for the accuracy, because we are saying it has to be recorded to 2 decimal places, and the last digit will either be a 0 or it will be an even number. So that is now why we shall be able to record that answer as 0.60, but not as 0.6. We are now basing that on the accuracy of this. That is how we can be able to take measurement of current using an ammeter. Meanwhile, we also have another instrument. This one is called a voltmeter. What is a voltmeter? What is a voltmeter? What is a voltmeter? Who has any idea of what a voltmeter is? Trevor still? Trevor, go on.
Voltmeter is an instrument used to measure voltage. It's an instrument used to measure voltage. And it measures its what in volts.
Very good. It is an instrument which is used for measuring voltage, which we sometimes call potential difference. In short form, we usually say it is PD. It is used for measuring PD across the ends of a conductor or across the ends of a load. So we measure this using a voltmeter, and then the voltmeter reads in volts. I just said the difference is when you look at the structures, it appears the same. The difference comes in from the interface, where you'll be able to see. Like here, you see there's on the interface, we have volts. But these voltmeters are also of different ranges. They are of various ranges. And the common ones that I think you are able to have in the various labs, the common ones we do have in schools is, there's one that has a range of 0 to 3. Then there's one that has a range of 0 to 5 volts, in which case we now have from the diagram there, that one we have from the diagram is the one from with the range of 0 to 5. It only has one, this time we have one scaled diagram for the voltmeter. For the ammeter, it was a double scaled ammeter. So there were scales both up and down, where we could make measurements in 2 ways. So from here, we can only make measurement in 1 way. So this is now the voltmeter that has a range of 0 to 5. You can see for this 0 to 5 voltmeter range, you have scales running from 0, 1, 2, 3, 4, and 5. The scales are at the intervals of 1. So if you now count the number of divisions that we have from 0 to 1, you will realize that there are 10. I want someone to confirm if those ones are 10. Elvis, could you confirm whether those ones are 10? Elvis, count whether those ones are 10. Nicholas, are they 10? Nicholas will also confirm as well. Are there 10 divisions between 0 and 1? Because that is where we're going to derive our accuracy.
There are 10.
Good.
There are 10.
Nicholas is saying there are 10. Fahad, your background has a lot of echo. Always ask that maybe you have your mic muted. For that particular voltmeter, there are 10 divisions between 1 and 0. So now, which means, what does 1 division represent? 1 division is now equal to 1 divided by 10. So when you divide 1 by 10, what do you get?
0.1.
Get 0.1. Good. 1 divided by 10, you get 0.1. So, which means from here, what will be the accuracy of this voltmeter? What will be the accuracy? What we actually refer to as the accuracy is the smallest reading, the number of decimal places for the smallest reading. That is where we can be able to make other readings from. That is what we call. Who's talking? Fahad?
Yeah. Now I get. Yeah.
You have got it?
Yeah.
We have 1 decimal place, which means now if we are to have recordings for this kind from this kind of voltmeter, so what we shall be doing is all our recordings are going to be to 1 decimal place. You can have recordings like when you have now 9 divisions for each in 1. So when you count this 1, because the number of divisions here are 9, and the unity division is equal to 0.1 volts. You want to get the reading of this PD, so it will be 9 times 0.1, you get 0.9. So if these ones are, if the deflection is up to that point, where maybe you have around 16, we have around 16 deflection is on 16 divisions. So you will say from here, this is 10, 11, 12, 16 here. You say 16 multiplied by 0.1. You'll get 0.1. 16 multiplied by 0.1. You'll get 1.6. But our recordings for this will go up to a maximum of 5.0. When your pointer is on 3, don't just now say that, there's already 3 there. Let me record only that 3. You will fail because you have not followed the accuracy. The accuracy is that all the recordings here are to 1 decimal place. So what will be 3 recorded as to 1 decimal place? 3.0. So you now put that answer as 3.0. If it is on 4, don't say, it is already on 4. Let me just put this 4, and that's my answer, 4 volts. You will not have got the correct recording, but the reading is right. See, the reading is right, but the recording is what? Wrong. The recording is wrong because you have not followed the accuracy of the instrument. The accuracy of the instrument is 1 decimal place, so we have to put it as 4.1. So that is all I can say about voltmeter. So is there any question about this? So those were the two of some of these important measuring instruments that I wanted us to look at before we can now move to the other concepts that are involved and we use in physics practical. Silence means that we can proceed. Now I want us to move to looking at rounding off. What is rounding off? Have you ever rounded off? Have you ever rounded off?
Yeah.
Yasin, have you ever rounded off a number or a digit? I mean a number to...
Yes, teacher.
Good then. So when you are rounding off, what were you doing? What is now rounding off? Who can define for us what rounding off is? Trevor.
Yeah, rounding off means making a number simpler but keeping its value close to what it was.
Very good. Making a number closer to say to the and then, but just as you have just said, keeping the value closer of number. Another? Elvis, you read for us this. What is rounding off?
Is approximating a given value to a certain number decimal place.
It is approximating a given value to a certain number of decimal place or significant figure. When you always rounding in mathematics, they say you round this to this number of decimal places. They will say you round it to 2 dps. They say round it to 3 dps, round it to 5 dps, round to 0 decimal place, round to 3 significant figures. Of course, mainly the concept comes with decimal places, but we know in so doing, we are actually trying to approximate a value which, as Trevor stated, there's a number that we are trying to change it. We're actually changing it, but we don't want to deviate so much in terms of its new value. So we are approximating that to a certain number of decimal places. We are now changing the number of decimal places of that given number. And in that process, we are approximating. So as we're approximating, we shall say we are now rounding off. So as we round off, when you're rounding off, there are certain things which you actually you have to do. So when you're rounding off, you have to follow certain procedures. But before we look at those procedures, I want us to take an example here. When we take that number, we have 2.634. This number 2.634 has 3 decimal places and 4 significant figures. When we talk about decimal places, what does it mean? Maybe someone has an idea. When someone will, maybe before, so we leave some other person behind. What does it mean when we talk about decimal places? We can visibly see that this number is what?
It means that numbers behind the point.
Numbers, eh?
Numbers behind the point.
Numbers behind the decimal point. In his language, that is what he has meant. Another person? Yasin.
The numbers after it is
Numbers after the decimal point. I think those, that's correct. Now, having got those two views, we can now all believe here that those numbers that come to the right of the decimal place, we can say that after the decimal place are now said to be called the decimal. They give us decimal places. Numbers after the decimal point give us the what we call as decimal places. So we count them. 6 is the first one, 3 is the second one, and 4 is the third one. So because of this, we shall say this number has 3 decimal places. But for significant figures, we shall say these ones are all significant figures. We are going to look at later on also the concept of significant figures in, I think, our next lesson. So this number has got 4 significant figures. Now when we round this number to 1 decimal place, this number will become 2.6. So here, as Trevor said, we are now trying to approximate a given value to 2.63 so that it is very close to it. You can see 2.6 is not very far from 2.634. Only that we have reduced the number of decimal places or the number of significant figures. Otherwise, it is the same figure. So here we have now rounded. Here we have rounded to 2 significant figures, but to 1 decimal place. Now, I just did say, when you are rounding, there are certain steps you're supposed to follow. In rounding off, they are supposed to follow certain steps. And these steps are as follows. The first step, Edwin.
Count the digits up to the figure in the required number of significant figures and approximate by applying one of the following rules.
Correct. Good. So what we do is we are going to first of all count the digits up to the figure in the position in the required number of decimal place or significant figure, and later we approximate by applying some also rules. So we shall have to count. See, the language is count. Now we begin to count from, according to this, we are counting the digits up to the figure in the position in the required number of decimal places or significant figures. For example, if we say round to 2 decimal places, so we shall count up to the number in the position of 2 decimal places. Are we together with that step? I first want us to understand that step well. When they say count the digits up to the figure in the position of the required number of decimal places or significant figure, which means now if they say round off to 3 decimal places, you'll count up to the figure in the 3rd decimal place. Is that okay? Are we together?
Yes.
Good. Then from there, we now apply some rules. One of these rules is this. Trevor, you read for us this.
Says add 1 to the preceding digit if the figure, I beg your pardon, says add 1 to the preceding digit if the figure dropped is greater than 5.
Let us work on this with an example. Straight away, we have to work on this with an example. We have that. You see, we have 0.2468. We want to round this to what? To 2 decimal places. Is it okay? So we're saying the first step is we count up to the digit. We count the digits up to the figure in the position of the required number of decimal place. The required number of decimal place here is now what? 2. So we shall count up to 2 decimal places. When you count up to 2 decimal places, we shall have 1. The first digit is what? The 2. The second one is what? The 4. Is that okay?
Yes.
The second digit is the 4. And the 4 becomes now our preceding digit. 4 becomes now what we call the preceding digit. Meanwhile, 6 becomes the the digit which is, the digit or the figure to be dropped. But now this rule says, add 1 to the preceding digit if the figure to be dropped is greater than 5. So you see, the preceding digit is 4. It is the number of the, it is in the required number of decimal places to which we're supposed to approximate. But the number we're supposed to drop is what? 6. Our problem is only between 4 and 6. We leave the rest of the figures. See, we leave the rest of the figures. So now, is 6 greater than 5? Is 6
Yes.
greater than 5? Now,
Yes.
if the answer is yes, so what we shall do is we shall add 1 to the preceding digit. When you add 1 to 4, it becomes now 5. That is why 0.2468 now becomes 0.25, and that is to 2 decimal places. Is that okay?
Yes, sir.
Are you very clear with that first rule? Adding
Yes, sir.
1 to
Yes.
preceding digit if the figure to be dropped is greater than 5. Now, just look at this. We have 2.37. 2.37 will become 2.4 to 1 decimal place. We are to round off here to what? To 1 decimal place. So we begin counting from the decimal point. When you begin counting from decimal point to the right, 1 becomes, one decimal, that one figure lands just exactly on 3, which means 3 is the preceding digit. And then what is the figure to be dropped? What is the figure to be dropped? What is the figure to be dropped right there? Uh-huh.
7.
Anthony. We're very good, 7. So we are dropping 7.
7.
Since now, Elvis is saying, Anthony 7, good. So the figure we're dropping is 7. Since 7 is greater than, 5, what we shall do is we shall now drop it, but we add 1 to 3, and then it becomes 2.4. It becomes 2.4. So that is how we can be able to round off using the first rule. Then the next one, let us look at the next rule. Now, the next rule is saying, Diction, can you just stop writing using the whiteboard? I've not asked you to use the whiteboard. The second rule is saying you add the 0 to the preceding digit if the figure to be dropped is less than 5. Now you see, this is simply just the example, the opposite of the first one. I'm running straight to the example here. Hope we're closely following this from our screen. We're closely following. We see what is the number we're supposed to round? What is the number we're supposed to round from the example?
It's 4.
So from here, we are rounding 1.6541 to 3 decimal places. What is the preceding digit? Preceding digit is going to be now the last digit. The preceding digit,
1.
the digit which will now be the final, which is at the 3rd decimal point. 3rd decimal position. 3rd position from the decimal place,
Oh,
it is a 4. Good. So when we begin counting from where the decimal place is, 6 becomes the first one, 5 is the second one, 4 is the third one. So 4 becomes our preceding digit. 4 becomes our preceding digit. And the digit to be dropped, or the figure to be dropped, is now 1. So 1 is less than 5. When the figure is less than 5, you add 0 to the preceding digit, which means you simply drop the rest of the figure. Even if there were other figures after the 1 here, what we know is the figure we're dropping is 1. Even if we had maybe 6 here after 1, the figure we're dropping is 1. 1 is less than 5. We drop it, the rest of the figures, including 1, and that follow after 1. So we shall be having here 1.64654 to 3 decimal place as our answer. When we have the next example, you can see the next example there. See, we have 0.1236. We want to round this to 1 decimal place. We want to round 0.1236 to 1 decimal place. So we count to the required number of figures. We count to the required number of figures to which we want to approximate. We actually want to approximate to 1 decimal place. So which means 1 step will actually remain here on 1. So this immediately becomes our preceding digit. And then the figure which is to be dropped is now 2. Is that okay? The figure to be dropped is 2. And 2 is less than 5. So we shall be able to drop the rest of the figures. Because 2 is less than 5, we add the 0 to 1. So this remains 0.1. These are the 2 common rules that we always see. These rules are only with numbers which are after 5 or numbers below 5. Then the next rule is with the next rule is now with the case where we have 5. If we now have 5. So if we now have 5, in this case, how do you go about with the rounding? If the figure dropped is 5 and there is no digit after 5, or there are zeros after 5, or even the preceding figure, just now, if the figure which were to drop is 5 and there is no digit after the 5, or there are zeros that have followed after the 5, we now look at the preceding digit figure, whether it is an even number or it is an odd number. So if the figure which is to be dropped is 5 and then there are no digits after 5, or we have zeros, we look at the preceding digit. If the preceding digit is an even number, we have to add 0. So if the preceding digit is an even number, we add 0. So if the preceding digit is an odd number, then we shall add 1. I want us to look at these examples. We are now looking at the case where we have 5. For greater than 5, less than 5, we are done. We are saying if now the figure which is to be dropped is 5, and there is no digit after the 5, or there are zeros after the 5, our attention goes to the preceding digit or the preceding figure. What is that preceding figure? Is it an even number or it is an odd number? If it is an even number, we shall add 0. If it is an odd number, we shall add 1. But the last option is actually a special case with that situation. You may have that the figure to be dropped is a 5, but we have other figures after the 5. So when there are other figures after the 5, what we shall do is we shall add 1. So let's have the examples now. We have this. The first one is this. See, we are to round 2.85 to 1 decimal place. What is the preceding digit here? What is the preceding digit?
It's 8, which is an even number.
It is 8, obviously, which is an even number. And the digit which is to be dropped from the statement there is what? Is 5. See? So because the preceding digit is 8, and the number to be dropped is 5, and there is no another figure after the 5, So what we shall do is we then add the 0. So it becomes 2.8. Is that okay? It becomes 2.8. Next, are we seeing? We now have here 1.95. We are to again round this to one decimal place. As we round it to one decimal place, you see the figure to be dropped is what? 5. Is it okay? The figure that was supposed to drop is 5. And the preceding digit is 9. Preceding digit is the number in the required number of the preceding digit is the number or the figure in the required number of decimal place we are to work out our answer. So because here we're to work out our answer to one decimal place, because now we have 9 and the digit to be dropped is 5. So 9 is an odd number. We shall add 1 here. So when you add 1 to 9, see, someone will say it takes you to, some people will now say it takes you to 1.10. That is wrong. When you add 1 here, it instead increases the value to what? 2.0. Is that okay?
Yeah.
Are we fine with that? Then now we have this last case. This last case is where we are supposed to also round to one decimal place. When we are to round to one decimal place, our preceding digit is what? The number in the required number of decimal places we are to round, which is 4. 4 is the number in the required. Then the number to be dropped,
5.
The figure to be, it is 5. Good. Figure to be dropped is 5. But you see, after the 5, we have other number. We have another number. So because we have other digit after the 5, we have to add what? We shall add the 1. If there was no number after this 5, which is 2 here, I think our answer number to be dropped, the 5 will be the number to be dropped. The preceding digit is an even number. Then we could have recorded this answer to 0.4.
Should have added 0.
Now, so that is all with rounding. As you're going to be working out calculations of values on table, even analyzing after the graph, you will be applying these rules in case you have anywhere to round off. There are basically, say 5, the preceding digit. If the number which is to be dropped is greater than 5, you add 1 to the preceding digit. The second one is if the number to be dropped is less than 5, you add 0 to the preceding digit. The third one is if the figure to be dropped is 5 and there is no another digit after the 5, and then the preceding figure is an even number, you add a 0. The fourth one is if the figure which is to be dropped is 5 and there's no digit after the 5 and the preceding digit is an odd number, you then add 1. The last one is if the figure to be dropped is a 5 and then there are other digits after the, there are other digits after the 5, So these are the rules that you're going to consider in rounding off. Now I want you to do this assignment and you drop this answer that WhatsApp group. Can we quickly putting down this? How many of you have been to round off the following to the stated number of decimal places? You have to round off the following to the stated number of decimal places. Let me just get this and then I'll be able to put for you on the chat there. So that is actually where we are going to stop. Those of you who have this week or even after Monday last week, we are moving on with yet free online classes, courtesy of the Yaaka Digital Network and Educare. We have a couple of services offered by Yaaka, which is just one of the products from Ultimate Multimedia Consult and Educare. I know you have gone over lots of this from the various we this are running. Is not give Mukisa and